Good morning, class. This is Mr. Walker here, coming to you with our next lesson for our unit of transformations. We are talking about reflections today. So, let's do a brief recap of what we've talked about with transformations so far. All right, so, brief review. We know that a transformation is a function that maps a figure onto a new figure. Now, there's four of them that we are going to talk about in the unit. So far, we've only talked about translations. So, translations move our shape from one position to another, but both are facing the same direction and it's still the same shape. Now, today we're talking about reflections. That is a transformation that maps every point across a line of reflection, and that makes a mirror image. So, here's our knight chess piece, and when we reflect it, it comes over that line. Now, note, both of these are the same distance away from this line here, and we have to make sure that they are both facing each other. Okay, after you reflect, you both face that same line. Okay, just like how you look in the mirror. All right, look, so we got to do a little bit of review before we jump up in here. So first thing we want to talk about are graphing some lines, because these are going to be the mirrors that we look at for our reflection. Okay, so here's our good old friend, the coordinate plane, back from Algebra 1 to tell us what we need to be looking at. So, we got a couple lines here on this. First off, we got the x-axis. Now, the x-axis, it's right here, highlighted in blue. It's horizontal. Now, note, all of these points here, they are just like a number line. Now, the left side here, that's our negative aspect of the x-axis. Right side, that's our positive aspect. Next, we got our y-axis. That's our vertical line right here in pink. Now, just like how this is a number line, so is the y-axis. It's just vertical now. The upper part of it, that's our positive aspect. The lower part, that's our negative aspect. Now, we got two lines that we are going to be dealing with in particular, and they are y equals x, and we're also going to deal with another one, y equals negative x. First, let's talk about what this is. This is an actual equation of a line that occurs on this coordinate plane, and we have to go through and graph it as such. So, this line comes across from the bottom left to the top right of our coordinate plane, and it goes through each of these boxes through that same diagonal, okay? So it's going up one over one, up one over one, up one over one, up one over one, and then it comes all the way up here. Now, this is one of our reflecting lines. I want you to keep this in mind along with the x and the y-axis. Our other version of this is y equals negative x, which is this green line here. Now, this is also going up and over one, but instead of it going up, it's going down. So think of it like you're going downhill for this one and uphill for this one. Now, other than these four basic lines, we also have other reflecting lines that we'll occasionally see as we go through the unit. Next one that we got, let's say if you had us reflecting over x equals negative 8. Now, if you have x equals negative 8, that is a vertical line at negative 8 on the x-axis. So this orange one right here. Okay, so you hop over on the x-axis, go over to where negative 8 is, and then you make your vertical line up and down. Likewise, if you have y equaling a number, like y equals 5, this is a horizontal line on the y-axis at 5, which is this purple line right here. Now, as we go through, these are just a couple of examples of lines that we will be reflecting over. These first four, these are the most common ones. These bottom two, these are ones that are, case by case basis, okay? But the main thing to know, it's a mirror that we are reflecting over with each of these lines. So just like how you look in the mirror, you're the same distance away from the mirror as your mirror image is. So keep that in mind as we go through this. All right, let's hop over into some notes. We're going to the big rectangle in the middle of our paper. So, talking about reflections, folks. A reflection is a transformation that flips every point of a figure over a line of reflection, and this creates a mirror image. Okay? So, this line of reflection, those couple lines that we just talked about, those are our lines of reflection that we will deal with from time to time. Now, the line of reflection, this is created by a reflected image with every point being the same distance from the line of reflection as its corresponding point on the original figure. So, both your image and pre-image for this type of transformation will be the same distance away from that line of reflection, okay? So they should not be any further. Just make sure that you're being exact with this. Go point by point, take your time, okay? So here's some common reflections here. We're dealing with the first four lines that we talked about. These are the most common ones. And if you're dealing with any of the other reflections that aren't on this, that means that you have to just make sure that your original point and your new point both are the same distance away from the line of reflection. All right, let's go through this quick. So, a couple of our common reflections. If you have a reflection over the x-axis, this takes whatever the y coordinate is of your point and gives the opposite sign. So if this was a negative, it would turn into positive. If it was positive, it would turn negative. The x value stays the same in this first reflection. Next one we got, over the y-axis, we change the x value to the opposite sign. The y value, though, stays the same. Then we got a reflection over y equals x. Now this one gets a little bit different, all right? Essentially what this does is it takes your original x and y coordinate and you switch your x with your y. Likewise, if you have to reflect over y equals negative x, it changes the x and y coordinate but also changes the sign of this. Think of these two here like you're looking at a mirror, but it's on like a slanted angle, not looking just straight at you, okay? You know, like how you take a picture with your phone at a certain angle or it's like looking up at you and not looking straight at you. It's like that. So, these four here, these are the four basic ones that you'll deal with, okay? Now we'll go through a couple of examples on our practice. First up, we're going to deal with these first two right here underneath our definitions. So, let's deal with what these reflections look like. So the first one we are reflecting over y equals x. Now, quick reminder from our chart that we just filled out. When we reflect over this line, what it does is it takes all of our x and y coordinates and it changes the y where the x is and the x where the y is. So let's look at our transformation. So y equals x is that diagonal line that we looked at. So it is, popping off over here from the bottom left to the top right. Then we change each of the x and y coordinates that we see here. So for instance, this one right here, this is -2 and positive 1, 2, 3, 4, 5, 6, 7, 8. So this is -2, 8. When we flip this over the line, this point will become 8, -2. Over here, we got 1, 2, 3, 4, 5. This is -7, 8. So this will turn into 8, -7. Down here, we got -2, 1, 2, -4. So this is -2, -4. This will flip over to -4 and -2. Let's take a look at our new shape, folks. Here's our new shape, y'all. Now note, since this part of the shape, let me go get that point. This part right here that crosses over the line of reflection is crossing it right now before we reflect it. That means that after we reflect it, it will also cross that same line. So these relationships will still keep that same, mentality with it. Like this point down here on the black shape is 2 spaces up and 2 spaces to the right from the line of reflection. So our reflected point should be the same distance away, just across the actual line. Just keep that in mind. The distance from that original line stays the same. All right, let's give you one more reflection. This time, we're reflecting over a non-traditional reflection line. This is x equals 1. So, here's our dotted line, x equals 1. Now, we want to make sure that we know where this shape is originally in accordance to this line. So, this point right here, we said this was negative 2, 8, which means that this point is about 3 units away from x equals 1. Now, this one over here, this is negative 7, 8, and this is about 8 units away from this. This one down here, this was negative 2, negative 4. This is 3 units away from this. So when we reflect over this line, those things, those distances that we had from this, will maintain it over here. Okay? So let's look at our shape. All right, so this point here corresponds with this point here, which means that they're both still the same distance away from our line. Okay? So 3 units away after, just like how it's 3 units before. 3 units away after, just like it was before. 8 units away before, 8 units after. Okay? It has to be a mirror image to whatever our line. So if we ever wanted to like fold our paper across this line, both of these shapes should line up on top of each other. Now, if you need a ruler as you're doing this, feel free to. If you want to color code it, feel free to. Okay? Color coding and using a ruler, that's cool. That helps you out with it. It's no problem. All right, so this was us graphing here. In our practice, over on the right side of your paper, we got a couple points here that we need to reflect without using our graphing. So let's look at what we're doing here. We got 3 points, D, E, and F. We're going to map them to D prime, E prime, and F prime after we reflect over the x-axis. So, quick reminder, what does that reflection look like? Our reflection over the x-axis has our original point, x and y. And the only thing that changes after we reflect over the x-axis is that the y value becomes negative. So we got y, our x will remain the same. Sorry again about how this penmanship's coming out, but you see me teach in class, so I'm not going to really feel too bad about that. So the y value turns negative, so that should be happening here. So in our first one, we got negative 3, 0. For D, in D prime, it will turn into negative 3, 0. This is because 0 here does not have a negative or a positive value. This is just right smack in the middle. So if we had to reflect it over that axis, nothing changes with it, okay? That's something that you should recall as we go through this. If you have a point that's on any of your lines of reflection, it will stay on the line of reflection after the reflection. It's just like if you put your finger on the mirror, it's not necessarily changing how far away from the mirror it is. It's right smack on the line. All right, so for E, we know that this has 3, 4. This 4 is the only thing that should be changing. So E prime will have E with 3 and negative 4. Okay, so the only thing that changes is our our y value. Everything else stays the same. Over on F, same deal. Negative 1 stays, negative 3 changes. Okay. All right, now, which type of reflection was performed from the pre-image to the resulting image? Now, we go through different reflections. So we want to go through, and if we look at this, we want to make sure that we know what's happening. Now, this is just a general change in reflection. So let's take a look and see what happened. So our first one that we had here, we had 3, 0. And then we saw, Extended that a little bit too far. Then we have 0, -3. So, note the change that's happening here, okay? Let's see if that change is continuing on. We had 4, 2. Now we have -4 in place of where the 2 was, and -2 in place where the 4 was. And then for our last one, we got -2, 3. Now we have -3, 2. So, what changed? We see that the x values have all switched to where the y values are. And not only that, the x value and y values have changed from whatever the signs they were originally to the opposite sign. So in this case, both of these were positive, they turned negative. The 3 was positive, it turned negative, and the 2 was negative, the 3 was positive. So the 3 became negative, the 2 became positive. What is this reflection showing us? This is actually the reflection of cross y equals -x. Now, if you look at your charts, you'll be able to see that. You'll be able to go through and deal with it, okay? All right. Now, you got these two here for you to practice with, okay? I want you to make sure that you go through, do that on your own, and then check with us on our online notebook to see if you got the answers correct, okay? If you need any help, feel free to ask me in class, and make sure that you do your practice that's on the rest of this lesson, folks. I'm going to catch you later.